this is Daniel from Worker B3D. Today I'll be demonstrating our automatic segmentation and reconstruction algorithm for bone structures, and specifically today we'll be focusing on a data set with the tibia and fibula as it says here. So I'm just going to go ahead and clear the command line and get ready here, so run that step. And I'm going to specify our image directory here is this VHF-me file, so we have to make sure this is in our directory and go ahead and run this section. So now from the files in our directory we're going to specify a few parameters for our 3D reconstruction. So that includes the sizing of the images, the voxel sizing, as well as the number of slices. So we'll go ahead and do that. And from that information we're going to create an image stack of all the 2D slices. So this will be called CT. So we're going to do a DICOM read of all the files in our directory and form that array now. So as is commonly done in the hospitals, physicians will normally view the images as they are in 2D. So if we go ahead and run this, this will bring up a montage display. Now you'll have to excuse my computer for being from 2008, but this will be brought up shortly so you can see. Okay, so here's our montage display, and as you can see, all the images are laid out in front of us in their 2D slices. Just trying to zoom in on here. So you can pan around and view each image individually, but as you can see, that's not a very effective means of visualization. So we're going to go ahead and view the middle slice in the stack. So this is actually just going to bring up the size of the file names divided by 2, so that will just give us the middle image. And this is going to bring it up using a function called imtool, so that allows for a few visualization techniques. For example, I can vary the image contrast here, and as you can see, just by varying the contrast I can actually isolate the tibia and fibula quite well here. So this means that this data set lends itself quite well to an intensity-based thresholding. So we'll go ahead and close that. So in order to specify the threshold of the image, we're actually going to display an image intensity histogram. So this is going to plot the intensity levels on the x-axis here and the number of pixel counts at that intensity. And you can see each peak here will correspond to a different material in the image. So here you've got your skin and your muscle here, and right up in the high intensity area this highest peak correlates to bone. So what we're going to do to try to isolate that peak is do a smooth curve fitting to this histogram. So I'm going to go ahead and run this, and you can see it brings up this smooth line here, and just by focusing in on this highest peak you can see that this is actually what we're aiming for to isolate here. So what we're going to do is we're going to run this section of the code, and what this is going to do is determine the peak locations as well as the valley locations here. So I'm going to go ahead and run this, and as you can see we've got peaks at these locations. So our highest peak here, 2603, that corresponds to about the average bone intensity here, and the valley 1146, if I just zoom out, that'll correspond to this valley right before this second highest peak. So what we're going to do is we're going to actually set all the intensity values lower than this valley to 0 here. So you can see we're defining our lower and upper intensity values here. So this is actually going to be the largest valley point, and we're going to go ahead and segment this. So I'm just going to run this. So as you can see, it's done quite a good job of segmenting the tibia and fibula here. We still have a bit of these small areas due to noise, and you can see there's quite a small endosteel surface here, so we're going to be looking to clean that up. But in order to clean up these smaller areas here, what we're going to do is use a region props command to identify all the different areas in the image, and all the areas that are smaller than the largest area we're going to set to 0. So we'll just go ahead and see the result of that. So as you can see, the largest area in the image actually corresponded to the left leg here. And as you can see, it's done quite a good job of cleaning up those smaller, unwanted small areas. So that's really good. And so that completes the segmentation. And then we're just going to go ahead and run, we're going to partition these areas and run a 3D patch based on the ISO surfaces. So I just forgot to call it. So here you have it, is our 3D reconstruction based on the 2D image slices. And you can see I can pan around here, and it's done a quite good job of giving us a clean representation of both the tibia and fibula here. So if I take so that's quite a satisfactory result based on this algorithm. Now just to show a few examples of what we can do to play with the segmentation. In order to do a better job at retrieving those endosteel surfaces, I'm just going to run the similar code here and get to the segmentation point here. So as you can see, instead of defining our lower intensity threshold as the value corresponding to the value corresponding to the largest valley, what we're actually going to do is we're going to pick the midpoint between the highest valley and the highest peak. And once this loads here, I'll be able to run the segmentation section here. So we're actually aiming, instead of selecting this point here, we're actually going to aim for something in this area here. So I'll just go ahead and call that up. I believe it was 1146. So this is doing a better job at picking that midpoint there. And as you can see, this this segmentation is quite a bit more accurate. If I do my manual segmentation in IM tool here, you can see that the endosteel surfaces are a lot less crowded in the segmentation. So that's a lot better. Unfortunately, we're having issues with this section of the code. If I go ahead and run the rest of the code, you'll see that upon reconstruction there are some issues with this segmentation method. So I'll go ahead and do that now. There. So as you can see, we're left with one, I believe this is a tibia here, and at the ends the segmentation kind of falls apart. You can see that the endosteel surface is a lot more well defined here. You can see a clean segmentation in the middle sections of the bone. However, it falls apart near the ends here. So this isn't quite what we want. Another thing we tried to explore is to actually smooth out the segmentation using edge detection and then apply a contour filling point. Here we're back to choosing the highest valley here. So we'll just run this. So there's our original segmentation, and what we're going to do now is we're going to try to locate these edge contours using a Canny edge detector, and we're just going to apply the default smoothing of square root 2 here. So we'll just pull up these edges just by running this section. Again, these processes take quite a while because we're applying them to an array of 300 images. So there we have it, is our edge contour is here. So similar to the paper we've been studying, what we're going to do is we're going to try to apply a contour filling technique here to try to clean this up. And there it is. So that's using IM fill. And you can see when comparing these two images, the smoothing from the Canny edge detection is actually quite effective. Gives us a nice rounded surface here and cleans this up. Unfortunately, with the IM fill command, we've actually lost, we haven't managed to preserve our endosteel surfaces. So that's one drawback of this technique. And I'll go ahead and we'll segment out the larger areas here, and we'll do the same 3D reconstruction. And I'll just show you the final result of this technique. And there you have it. So there's our three-dimensional reconstruction, and as you can see, the surfaces on this are a lot smoother than the first pass. So this is quite a successful reconstruction. Unfortunately, you can see here on the bottom the endosteel surfaces are not preserved. So this is due to the IM fill. So we're gonna complex. So here's the last function or section I'm going to show you here. So we're just going to do the same here. We're going to run the segmentation again using the highest value point. Let's go ahead and run that. And similarly, we're going to be using the Canny edge detector with the square root 2 smoothing just to locate those edges of the image. We'll go ahead and run that. So there's our Canny edge detection as we had it before. So what we're doing this time is we're going to apply a bit more of a complex contour filling, trying to maintain those endosteel surfaces here. So what this is actually based on region props. We're looking at the filled areas here, and it's going to index the pixels in these filled areas and try to outline the holes that we're about to fill, as opposed to the IM fill. And once those inner contours are identified, we're going to apply pretty much an identical code here, and we're just going to go ahead and remove the small areas within the image. Maybe I'll just run this so this section doesn't take too long. So here what we have, it's defined, it's filled in the contours, but it's actually outlined the filled holes. And if it allows me to zoom in here, I'll show you. Sorry, just give me 1 second. I think it's still processing the second section there, so we might have to wait a minute. Here we are. Uh, so if I zoom in here, you can see it's filled in the holes, but it's identified the edges around these holes. And then we go ahead and we remove the small areas in hopes to preserve those endosteel surfaces. And what we have is we end up actually segmenting just the large bones here, but you can see the endosteel surfaces are quite well preserved. As well, we have a very smooth contour around here. So I'm just going to go ahead and complete the 3D reconstruction and show what this looks like here. So there we have it. As we can see, our more complex contour filling approach is not quite as robust. It ends up segmenting, but it's looking pretty smooth overall. So this needs to be cleaned up, but it is another approach just for the segmentation and does quite a good job here. So just want to back up to where we started here with the video. our basic algorithm. So this is just, again, this is just defining the valley, the largest valley point, and doing a global thresholding based on that. Then we clean up the largest area. Apply this, we're going to try out a different database here. So we're going to try the HIP database. And this is going to take a while. It's going to bring up all the intermediate images here, but I just want to show the final result. Just that this algorithm is quite robust and works across a wide variety of databases, not just for the tibia and fibula. So I'll just allow this to load. So there you have it.